All right. I think we're live now. Can everyone hear me? Can I get some thumbs up on the chat? Yes, that's good. I see Patrick, I see Andy, see some yeses, thumbs up, awesome stuff. All right, so hello everyone. I'm Alejandro Ferrero, the Google DSC lead at Politecnico di Milano. And first of all, I would like to thank all of you for joining us today. And I would also like to give a special shout out to all the students that join our DSC community at PoliMi. We had hundreds of students joining in the last week because we made this announcement about blockchain, so that's awesome. We currently have over 1,000 students in our Telegram group, and the rest of our social media profiles are also growing thanks to all of you and your engagement in this community. So yeah, basically on behalf of all the core team members, thank you so much for that, because we really appreciate your involvement. And moving on, it's time to get started with this amazing event today. As you all know, we're hosting a 2-event series about blockchain in collaboration with Chainlink and The Graph. And today we're honored to have Patrick Collins and Andy Boyan from Chainlink Labs, who will be presenting this first event of the series. So with all that being said, I hope you all are ready to have a good time, to learn a lot of new things about these fascinating technologies. So Patrick and Andy, it's all yours now. I'm gonna hand it over to you. I'm gonna stop sharing my screen, and you can take it from here. So
fantastic. Thank you for the introduction. I'll get sharing my screen here in just a moment. Uno momento. New systems, new sharing. All right, let's see if that worked. All right, you guys got that? Fantastic. Hello, everyone. My name is Dr. Andy Boyan. I'm really excited to talk to you about Chainlink today. Thank you to the DSC group for inviting us. This is kind of fortuitous for us at Chainlink Labs, as we're putting on a hackathon starting next week, and we got a chance to come talk to a bunch of student developers. The stars aligned, and that's fantastic. So but I'm going to start and give you kind of an overview of what Chainlink is, what makes it exciting to me and to us and Patrick, and how it fits into the larger landscape of smart contract applications and developments. And then I'll hand it over to Patrick, who'll give you more of a technical demo, introduce you to Solidity, and really make a push for you all to register for our hackathon for sure. So my background, I'm a former professor. So I was in academia. I studied digital systems from a social science point of view. And what I was always really interested in was how technical systems influence social systems and vice versa. So how do people interact with social technical mechanisms, and how does that influence their interactions and their perceptions and all that stuff? And so when I found out about blockchain, it was like a whole new world. It was a revelation, and especially when I found out about smart contracts and thought, this is a way that agreements are revolutionized, where we can have digital value, we can transact with it very securely and transparently. It was just mind-blowing sort of revelation that I had a couple of years ago. So I left academia, I got into industry, and I've been working in the blockchain industry for a little while for various projects. For the last 6 months for Chainlink Labs, because what we do is directly related and pretty core to smart contracts and making really cool applications. So, smart contracts have this ability to change the way that people interact with systems, automate those systems, and interact with each other. But really to do that, once we start looking at smart contracts and getting excited about that, what we need is good data into smart contracts. And that's a major problem. That's what Chainlink's here to work on. So Chainlink Chainlink is fundamentally software and a network that runs that software to ensure that we can get data onto blockchains. Because smart contracts and blockchains fundamentally are unable to connect with external systems like data, APIs, Internet of Things data, any kind of data. Blockchains can't access it. And there's a really good reason for that. They're not supposed to. Here we have Ethereum is in the blockchain box, but it's any blockchain. They're not supposed to because they need to maintain determinism and homogeneity inside the blockchain. And so if nodes of a blockchain are calling APIs and getting different data, there's all different values of APIs. There's all different nodes maybe calling different APIs. Let's take an example here from New York Stock Exchange. If you call a price, for example, a price for an API, well, the New York Stock Exchange may have a slightly different metric than the Tokyo Stock Exchange. And so who's right on a blockchain? That's a problem for coming to consensus. So oracles aim to solve this problem. So you look at all this different kind of data, and to make data interesting and connect onto blockchains, we got to figure out a good way to get it there. And that's what smart contracts are all about, and oracles are all about. So an oracle is a device that interacts with the off-chain world to provide data to smart contracts. It reports the results of the data on chain so the blockchain can stay deterministic. So it formats that data in a way that blockchains can understand, that won't break determinism and break Bitcoin, break Ethereum. We don't want that to happen. That would be a tremendous value lost. So oracles actually enable you to do a lot of really cool things. Once you can access external data, different kinds of data, you can do neat things. So we've got this oracle, which is essentially middleware in between data and a blockchain. And so we can look at a system that looks like that. We've got external data over here on the side, sports scores, price data, IoT data, whatever it happens to be, comes in through an oracle, and the oracle submits that to a blockchain. Well, you notice in the blockchain, it's Ethereum here, but it could be any blockchain. We've got thousands of nodes. We've got this great decentralized infrastructure. There's like 8,000 nodes on Ethereum, providing this really robust, really secure consensus mechanism. Well, but then in the middle, you've got a single oracle. That's a problem. That's a point of failure. If Patrick's running a node and he's the only oracle, and he gets his house gets struck by lightning, there goes my data. I don't have it anymore. And so my smart contracts that rely on that, they're out. Or if Patrick decides to be evil, because he's not evil, but if he decides to be evil, and maybe he's got a financial stake in that data, and he could manipulate data in a way or go to a data source that will benefit his outcome in a way better than my outcome. Well, I've only got one oracle node, so I don't have a lot of opportunity to say security there. So we say no to centralized points of failure. We're in decentralized systems. So here's what we do. Chainlink is a solution. It's a decentralized oracle network. So instead of a single node, we have multiple nodes, multiple oracle nodes that are coordinated, working together, yet independent. So they're using a kind of consensus, not the same as blockchain consensus, but a kind of consensus to keep each other honest and incentivized. They're also incentivized to go and get good data and data from multiple sources, and then submit those to blockchains. And that way, we are protecting data with the resiliency, the robustness, the decentralization that gives us security guarantees and reliability guarantees similar to blockchains. That's what Chainlink's all about. We make the software that facilitates this. We help make sure those nodes and data providers and smart contracts are aligned, that people run their software and update their software correctly. We do education and outreach as well at Chainlink Labs to help more developers find out, if I want to build a smart contract, how do I get there? I need an oracle. Here's a good oracle, a secure oracle. This is the Chainlink model right here. It's not just APIs, it's any input that we strive to take. Internet of Things data, web data, a variety of different things. This is all plugging into Ethereum in the middle, but like I said, it can go to any blockchain. And we can use the same infrastructure to take data and take it off of blockchains to legacy banking systems or payment rails or other blockchains. You can have Ethereum talk to Polkadot, talk to Avalanche, etc. So here's a model of our solution. This is like the network in action in a DeFi solution. So we've got a number of different solutions. DeFi is our most used one. We have price feeds. So if you think about the Bitcoin blockchain doesn't care about the price of Bitcoin. It cares how many Bitcoin I have and how I'm going to send them, if I send them, whether or not it's true that I sent them to one place instead of trying to send them to multiple places. So Bitcoin doesn't really care about the price of Bitcoin, but smart contract applications might, or whatever asset it happens to be. So in this example for DeFi, if we want to do a change at a given price value for an asset, we've got to go off-chain to markets, to exchanges. So let's just run left to right real quick. We've got hundreds of exchanges that trade crypto assets, and that's where price discovery happens. Some of them are very deep liquidity, some of them are very low traded markets, but there's a ton of them. What we have is a network of data providers. Many data providers will go and collect APIs from those exchanges, aggregate that data, and make a much stronger indicator of the actual price. In that way, if you've got a price that's a big outlier, it's way off, that can get smoothed out in the aggregation curve, or in a median, you just remove the outliers. Then we have Chainlink nodes, which are the Oracle nodes that are calling data from the data providers. So already we've got multiple Chainlink nodes calling data from multiple data providers, calling data from, in total, hundreds of exchanges. So now we're decentralizing that data, coming to a stronger, harder, more resilient price that then goes into a reference contract, which is like what the smart contract accesses. And then the smart contracts, the users over here, are smart contract applications. And if you're familiar with the space, you'll see Aave in there, Synthetics in there, a lot of the major users. That's the Chainlink network in a snapshot when it comes to DeFi prices and price data. We actually have these live. You can go to feeds.chain.link, and you can see this is a visualization of on-chain data, and it's updated very regularly whenever the price updates on-chain. This one's not too old, but you'll see the Ethereum price is very different than what it is today, but it's not that old. But it shows you all, around this whole node, all the different node operators, Figment Networks and Everstake and all them, and the price that they submit. They come to an aggregation and take the median value, which is that price that's in the center that is submitted on chain. And you can see this in action. So we try to be transparent as well. And as a heads up, this visualization will be changing very, very soon. We're getting just a new interface for it. So if you don't see this when you go there, don't worry. It's gonna look really cool. I'm gonna skip this for the time's sake. Why is this important though? Why do you want good data? DeFi, man, it's not just a couple of niche developers trading CryptoKitties anymore. They're serious money. This is from this morning. We've got $42 billion locked into DeFi protocols, and that's just those that are being tracked by DeFi Pulse, which has a lot of them, but still there's plenty of change there. And you'll see that graph, it starts out real flat, and then starting last year, around this time, it starts to make a serious curve. More and more value pouring in, and at Chainlink Labs, what we're about is making sure that the infrastructure is in place so that those billions are secure. So that when somebody locks money into a smart contract, they can be confident that they have the right price. If I'm going to collateralize a loan, when I take out that loan, I'm not going to get liquidated because there's an incorrect price oracle that misreports data or that is manipulated. And we see those attacks all the time. That happens, either unreliable oracles or people don't maintain theirs, or there's a centralized source. And you'll see those headlines frequently if you pay attention to the space, but not with Chainlink oracles. Because we use this decentralized model to make really good oracle infrastructure. So the interest in DeFi, as the infrastructure has increased, has also increased. Chainlink oracles are used by some of the major top players in the space. This is just 4 of them, but we have hundreds. You can find more on our feeds page, many users. But DeFi is not our only project or our only product. We also do a few others. There's one called Proof of Reserve that shows how much a given protocol has locked in reserve, so you can audit them transparently on blockchain. The one I have on the screen now is Chainlink VRF. I'm not going to go into detail about the mechanics, but it's a way to get provable RNG, secure provable RNG. You know it's not being manipulated, and there is an on-chain proof that you as a user can go and verify. We're seeing projects start to use VRF for to determine rarities on NFTs. So NFTs have value at different rarity levels. Well, you want to assign that in a random and fair way to give every user a chance, like opening a pack or something like that. VRF can help with that, and there's a ton of other use cases on that one. And we've got this great blog post I want to encourage you guys to check out, 77 smart contract use cases. It's incredibly long and incredibly awesome because it's like one of the most fun things to read and write and talk about. It's like, well, what could we do with a smart contract? If you have the world of data at your fingertips, turns out we can do a lot. DeFi, of course, there's more and more traditional finance tools that are coming on chain. So we're getting a lot of leverage products and margin products and options products, things that people can do once you have secure collateral. If you know your collateralization ratio is accurate and secure, then you can be confident in putting more money into a protocol. And so we see that again and again with many projects. Gaming, there's a ton of gaming options. Fantasy sports is a great example. This is Patrick's example, but I had to just take it and run with it because it's like this perfect smart contract mechanism where if you're into a fantasy sports league, you get a bunch of people and they throw $100 or €1 or 50 euro into a pool, and then you rely on data to tell you the outcome, and then you rely on your friend Fernando to pay whoever the winner is. And we don't have to worry about Fernando anymore. We can actually just get that automatically distributed to the winner or the top 3 winners because we have good data coming from a good data source. Smart contract automates all of that, pays out. There's some really fun opportunities there. There's some really interesting work on tokenizing assets. And again, this ties back to some of the NFT stuff that you've probably been seeing in the news lately, where we can't smash up this car and put it on the blockchain, but we can tokenize the certificate of ownership. And we can tokenize certificates of originality and things like that. And once you have that, well, then that becomes really interesting even for art. Certificate of ownership for an original piece of art or collectors and all these things that you're starting to see in the news. Now, we've got a ton of other use cases. We're one of the highest used pieces of infrastructure in the space. Insurance alone is there needs to be a whole semester-long course about decentralized insurance and automated payouts based on weather data and secure weather data. It's really changing the way people who don't have access to traditional insurance markets are able to provide themselves with a more safe and secure life in their farming and crops. Those products are live now, and they're really, really compelling. You can make your own use case and develop your own stuff at our amazing Chainlink Hackathon, which my friend Patrick is going to talk about in just a minute after he gets into the guts of Chainlink. I want to thank you guys for being patient with me as I get to talk about one of my favorite things. And then I'm going to turn it over to Patrick, who also gets to talk about one of his favorite things. Take it away, buddy.
Yeah, for sure. And once again, thanks everybody for having us on. Really excited to be here. Really excited for the turnout. So whereas Andy kind of went over a lot of the conceptual, really important information there, I'm going to be going a little bit more technical, be diving into the code and showing you guys more about how it works. And I actually see there is a little bit of Q&A here. We'll pause real quick. So despite ETH current scalability issues, do you feel it's still superior to any competitor? Would an eventual shift to another chain be troublesome or easy? So I don't know, Andy, if you want to take this one or you want me to take it?
I have personal opinions that we're heading for a cross-chain, multi-chain future, and that there's strengths and weaknesses of every chain, and that apps will find a home where the technology is suited for them. So you look at something like Polygon, formerly Matic, they're making a really hard push to do gaming on Matic, and they're doing a great job. And it's fast, and it's built as a layer 2 on top of Ethereum, so it can settle on Ethereum. That's a strong potential there. Or you look at a Solana and how they're integrated with FTX, and so they're trying to make a really sophisticated trading engine on chain, and there's a lot of potential there. So that's just my personal opinion. I think there's room for many chains and many applications.
100% echo that sentiment, and that's the reason too why Chainlink is a blockchain agnostic technology. It can work on any chain, period, which is really fantastic. We'll do one more question, then I'll jump into the technical demo. Is Chainlink compatible with the Cardano blockchain? Therefore, is it possible to use, instead of Solidity for smart contracts, to use Plutus? So Cardano actually doesn't have smart contracts available yet. So technically nothing's compatible with Cardano yet. I know that they launched something recently, but I'm gonna be honest, I'm a little bit out of the loop with them at the moment. But yes, so once kind of the roadmap for that is out and Cardano has kind of the smart contracts built, Chainlink network will definitely pop up there as well to help give them decentralized data as well. So
sorry to interrupt you, Patrick. I think what they launched is the Mary mainnet or something like that. I think that's the name of it, but I also have to look into it just to point that out.
It's Mary mainnet. I think it still doesn't have smart contracts, but once they have smart contracts, I mean, we'll look into it. Chainlink is built and designed in a way to make it modular enough to basically adapt to any layer one. So the question isn't will Chainlink work? It's like, when will it work? And hopefully soon. So hopefully very soon, whenever smart contracts come out. So cool. So I'm going to jump into the technical demo now. I see there are a couple more questions. Feel free to let them roll in. Honestly, I will be. I will do I'll do a section, jump to the questions, because I really like these to be very dynamic and very interactive, because I know a lot of you guys some of you have Solidity experience, some of you don't. So we'll kind of be just briefing over what we're doing in these examples, and feel free to ask a ton of questions. So here is the Chainlink documentation, and again, right at the top, we have join the Chainlink Hackathon. The website looks so sick, but yeah, there's tons of prizes. Like literally the entire industry. Some of the biggest names in the industry are participating or joining in some way. Down below, we have the workshop schedule, which I know a lot of you are looking to learn more about Solidity and get into Solidity, and maybe some of you are even very advanced. We're going literally from intro to blockchain to everything Chainlink, DeFi, Brownie, Truffle, Hard Hat. Truffle, Brownie, and Hard Hat are smart contract development frameworks for deploying, maintaining your code really easy, building and using and selling NFTs, testing, multi-chains, Chainlink nodes, external adapters. It's everything in the kitchen sink. And this is just some of the ones that we're doing. Each one of these sponsored technologies is also jumping in. Yes, including the graph, 100% including the graph. The graph, Solano, Polkadot, it's all over the place. So there's this massive amount of technologies that you can use. You'll get to network and meet many of the brightest people in the industry, and you can actually partner with them on a project, build something really cool. And this is really where we see a lot of people network and meet a lot of people in the industry who they'll probably stay connected with for a long time and have that relationship with. We've seen a lot of people get hired from hackathons who do really well. We've seen a lot of people show up to a hackathon, get on stage, they go, I had no idea what I was doing this hackathon, but I tried it, and we absolutely love that because there's this huge, unfortunate thing in the software engineering world where everyone feels like an imposter, called imposter syndrome. They feel like they don't belong. You absolutely belong. There's going to be a ton of new people here. There's going to be a ton of experienced people here. Everybody from every walk of life shows up, build something cool, and it's a great chance for everyone to get connected here and build something awesome. And then, if you don't build something awesome, you come back to the next one and you'll be that much better, and you'll be that much closer to being where you want to be. So, or maybe you show up and you just absolutely crush it. In any case, it's a learning, growing opportunity to meet some awesome people, win some awesome prizes, learn about some of the cutting edge best technologies from some of the best in the business. And definitely recommend anybody who's looking to get started with Solidity or get started with blockchain, or already is really good and they want to put their skills to the test. This is definitely a place to show up. But anyways, we'll go back to the documentation. I pretty much live in the documentation here. I come here pretty much every day because I code every day. And it's a really easy reference point to kind of come back and be like, okay, what do I want to do? So we're going to look at using price feeds, which is that kind of pre-decentralized network that Andy was talking about. So if we go to price feeds here, this using price feeds or using data feeds is going to be the section that we're going to look at. And we can even go to data.chain.link, and we can see a visualization of this, again, like Andy was saying. And we can see like exactly what these look like. So here's an example of one of these decentralized networks. So all of these little dots around this, these are all independent Chainlink nodes. And you can see the answer that they're reporting. So each one of these is grabbing the price of Ethereum in USD, which right now it's a little bit north of 1,800. And they report that data on chain, and that data gets aggregated so that every developer in the space now has kind of this community resource to pull for their dApps. And again, these price feeds are being used by DeFi protocols like Aave, like Synthetics, like these massive giants who are securing billions of dollars. I think they're helping secure something like $10 billion right now. So these are battle tested, been in use for a long time now, and just show kind of the strength of the decentralized network. So this is what we're going to be looking at. We're looking at accessing this pre-decentralized price, right? Because that's one of the main kickers here is we're getting this data not from a single source. If one of these nodes goes down, and we can even see here, like if this, like maybe it's a UI bug or maybe this node is down, it doesn't matter because the network is decentralized. So maybe this node caught on fire and exploded and all their backups exploded. Maybe all of these nodes over here, all of them catch on fire and explode. The network persists because it's decentralized and it's highly resistant to Sybil attacks, highly resistant to malicious actors, because it's decentralized. And again, this is the narrative that you'll see more and more in the smart contract in the blockchain world. So how do we get this? How do we get this data? Let's look at this. So in the documentation, there are these nice little buttons we can click, which lead us to the Remix IDE. This is a web IDE for those of you who are familiar. It's a integrated development environment. And what will happen is on the side in the gists, it'll pre-populate the code. I've been doing this all day, so I have a bunch in here. Actually, might have even screwed this up. Oh no, I didn't. Okay, cool. Because I was fiddling with the code earlier. But we can see the code in front of us, and this is Solidity. The syntax for this is Remix syntax. For any of you who are familiar with like Truffle, Hardhat, Brownie, you would just, instead of doing this import github.com, you would just do import like at. And import the package. And you can see the different syntax here. So that's the only difference between Remix and using like Hardhat or something. But I'm going to jump into the code a little bit because I know a lot of us are less familiar with Solidity. First thing we do is we define the Solidity version. So we're going to use 0.6.7. We're currently at, Solidity just launched, I think, 0.8 recently. They iterate really quickly. New versions come up and there's new patches and stuff, but this is a pretty stable version that we like to kind of demo. You name the contract, which is similar to like a class in Java or really any object-oriented programming language. And then we're going to initialize our aggregator v3 object, give the visibility of internal, and call it price feed. So this is actually imported from our import right here. You can see we're importing this aggregator v3 interface, and it's literally grabbing like the Solidity file and just plopping it at the top of this file here, so we can use any of the functions, any of the classes, any of the contracts from this file right here. And what we want to do is we want to reference the address of this aggregator. So remember how I showed you this picture right here? It has an address on chain. So this is Etherscan. For those of you unfamiliar, it's a popular way to kind of view the blockchain and see what's going on. This contract has a unique address, and we want to reference this address when we want to reference the price. We want to say, hey, let's go to that address, and I want to get the price because that address is reporting it. It's different because we're going to be using what's called a testnet. So we're using a Coven testnet, which is a also, if you guys are like, yeah, we all know this stuff, feel free to pop that into the chat as well. I'm actually scrolling down. Okay, cool. Yeah, I don't see anybody saying, yeah, this is old news. So if this is old news, let me know. So we're going to say we want to get the aggregator v3 interface of this address. And we're going to call it price feed. And then what we do is we have one function that just is called get latest price. And we're going to take this global variable basically called price feed. Great. Hey, honestly, I never be knowledge shamed. If you're unsure, all new for me. I absolutely love that. Welcome. Yeah, please don't ever be afraid to say I don't know or I don't understand. So we're going to call price feed.get latest round data, which is like going to return all this data here, the round ID, the price, when it was started at, the timestamp answered around, and then we're going to return the price. So to deploy this, we're going to compile it. I hit Control S, or you hit the big compile button, and then we're going to deploy it. So the JavaScript VM is kind of like a fake network. We're going to be using injected Web3 because we want to work with a test network. And we have MetaMask installed, which is how we're going to interact with these test nets. MetaMask is a browser extension that is also like an Ethereum wallet or a crypto wallet. You can download this. You can learn how to get this testnet ETH. Don't worry, I don't actually have 63 ETH in this wallet. This is testnet ETH. But we have a couple of videos in the Chainlink engineering tutorials on YouTube. And in the documentation too. If you ever get lost, literally this entire tutorial, like start from beginner or start to finish, is in this beginners, the basics. I'll even link this in the chat here. And it goes through everything. If you don't know anything about smart contracts, if you don't know anything about Solidity, if you don't know anything about MetaMask, this will get you set up and basically go through what we're going through here as well. So anyways, back in Remix. So we've compiled. We're going to use the Kovan testnet to deploy the smart contract. We're going to go ahead and hit deploy. Andy, can you guys see MetaMask pop up or no? I don't think you can. No, okay. Never mind. Well, all right. So because the screen sharing is a little bit weird, but MetaMask popped up. It's asking me if I would like to confirm the transaction. I'm going to go ahead and say yes. And what's going to happen is we get this link to Etherscan, which says our transaction is currently being processed or mined, really, right? And this is a test net, so it resembles and signifies basically exactly what would happen on a real, like as if this was real money and as if this was real Ethereum. So it says transaction has been included, will be reflected in a short while. It's probably already on, but Etherscan's taking a second to render. And we can actually see down here, this deployed contract section. We have this contract right here, price consumer v3 at blah, blah, blah. This is the contract address that we've just deployed. And we can hit this get latest price function, and we can see we currently get back the latest price in Ethereum. Now, obviously, the next question is, why is it such a wonky number? And the reason for that is Ethereum actually can't understand decimals. It doesn't work with decimals. So you have to, so for these pairs, for these like fiat pairs, they have 8 decimals of precision. So this is actually 1,847. And 99 cents, etc. But that's how we get the latest price into our smart contracts. And then what can we do with this? Well, now that we have really solid data, any of you who've done any type of software engineering with quantitative models, or trying to build any type of aggregators or decentralized exchanges or whatever, this is probably going to be one of the fundamental cornerstones of your application, getting really reliable, highly secure, decentralized data. And again, we see protocols like Aave, who does lending and borrowing. They're using these prices to actually have the asset, have the price of the asset for their lending and borrowing platform. Something like Synthetics, which is a derivatives and DEX that actually uses Oracle or Chainlink-based prices to price their assets on their decentralized exchange. They also make synthetic assets, which is this other mind-blowingly fantastic innovation, and a number of these other protocols. I mean, these are, especially in finance, where prices, having accurate, solid prices is so quintessential to the application. This is the cornerstone of their application right here, and it's really as simple as that. And let's jump into some questions. So I'm going to pause now, jump into some questions. How much time do we have left? 20 minutes? When does this end? I think we have 20 minutes, right? Yeah, we're not sure. Okay, we'll do a couple questions.
There's no rush, Patrick. If you need a little bit more time, feel free.
Cool. Just want to make sure everyone gets to. Please use Q&A feature. Okay, gonna go to the Q&A feature here.
We got philosophical blockchain questions, and I love them.
Okay, cool, great. So answered this. What do you think of EIP 1559? Is it going to change anything for you, Chainlink? Great question. I feel like this is definitely a more philosophical question. Basically, it's not going to change anything as far as Chainlink is concerned. Same thing with like ETH2. It's not going to change anything. What do I personally think of it? Yeah, I can't really speak for anybody else. I think it's there's a lot of really good ideas there. I think it makes a lot of sense. I think there's a reason that it's kind of finally being improved. I haven't done enough research to say I have like all the backups or all the knowledge to kind of really defend why I think it's cool. But I think from a basic perspective, yeah, like having kind of burning the E to have that base layer, I think makes sense. But yeah, I haven't done enough research. I don't know, Andy, if you have any other thoughts on it.
I'm skeptical. I don't think it'll change network performance for us for certain. Like there's still going to be fees and they're still going to be relatively high given the network demand. What I really hope is that the user experience of deciding what fees to use is improved, because that's one of the intents of 1559. Because I've been using DeFi for a few years, and I didn't realize that we didn't call it that in 2017. But and getting an advanced settings on MetaMask so that you get your gas costs to the precise moment where it's the cheapest. Like it actually takes quite a bit of effort. And I'm a non-technical guy, but I try to explain this to even technical friends or experienced front end React developers, and they're like, whoa, I don't get this. I'm like, you just do the drop down menu and twiddle the thing and do that. So I've realized that is a significant barrier. And so I really hope that it helps in that, but I think it remains to be seen how actual users manage their gas costs and transactions.
Yeah, I think that makes sense. So cool, good questions. Keep them coming. Does Chainlink and
Patrick.
What's that?
Oh wait, no, go ahead.
Oh wait, what were we? Oh, okay. Were we? All right, I'm going to keep going. Does Chainlink and other decentralized oracles really eliminate trust? Or is it just a matter of hindering the risks associated to using a single centralized oracle node? This is a great question. So in the same regard that Ethereum works, right? Ethereum is decentralized computation. It's these decentralized smart contracts that you're basically eliminating trust, or maybe a better word is saying trust minimized agreements. These trust minimized agreements, because they're being run on 8,000 nodes, right? And counting, right? So because of that, you have this decentralized algorithm, and they obviously want to behave. And if they report something wrong, they get penalized. So they're highly incentivized to report and actually execute correctly. So in this sense, yes, it's highly trust minimized to the point where one would even consider these smart contracts, these agreements, trustless, right? And that's the whole purpose of blockchain and the whole purpose of smart contracts. Chainlink acts and behaves in the same manner, right? If these nodes don't respond appropriately and don't reach the consensus, they're not going to get paid. The economics won't make sense for them. So they're highly incentivized to report appropriately, and you're not relying on a single one who can get paid off. It's kind of the same thing as like the way to hack Ethereum would be for you to run around to 8,000 people's homes, or however many homes out there have Ethereum nodes, and hack half of them, right? So it's the same thing with Chainlink. You'd have to run to everyone's. So Chainlink is removing this centralized point of failure from your smart contract applications on the data layer, right? And that's the difference. So whereas Ethereum, well, on the data and anything external, really, anything off-chain, where it could be off-chain computation, making API calls, whatever. Whereas Ethereum does kind of this decentralized computation, Chainlink is this data, this off-chain computation layer, and that's really how it's defends against any centralized issues. Good question.
Yeah, see, I love this question too. I'm going to take a philosophical approach, because trust, I think, is a really tricky word with human interaction.
And then
humans are never going to eliminate trust. It is a fundamental, evolved, psychological, millions of years of evolution into what we trust and what we don't trust. It's what do we decide to trust, and who do we decide to trust, and where do we want to put our trust? And I use DeFi. Have I verified for myself those contracts? Nope. And not most of them. I have smart friends who have. And so I know that they can be verified, and people have verified that I do trust, but I trust those people. I can't do that with my bank. My bank has my money, and they lend it out to people, and I can't verify that. There's no way to. So it's a shifting of the trust. So from a philosophical perspective, I don't think we can eliminate trust. I just don't think that's a possible thing for humanity. But I think that we can change to systems that enable people to verify as opposed to have to trust, and to build additional auditing systems. So for example, proof of reserve, we've got another solution that takes a look at reserves of a coin. Like they have Bitcoin locked into smart contracts so that they can mint synthetic Bitcoin on Ethereum, for example. It's a REN BTC. We can verify, we can go and see what's in that reserve. You don't have to, but you can. And so that really changes like how we think about the world. What can we verify? What have people verified? But yeah, the trust layer, people don't trust epidemiologists who have studied for decades. We just in COVID right now, there's still a lot of issues with trust in society. Sorry, that's a fun question to delve into.
No, 100%. That is a fun question. And yeah, I'm going to try to get to the end of this question list, and then we'll do another technical demo because I see a couple questions with a lot of thumbs up. So we want to get to those. So what about the relationship between governance and innovation? Do you think that today's legislation behind this world is okay, or does it limit your work somehow? Should it be improved? I think these are kind of like some philosophical, personal questions almost here. It's like, what do we personally think? I used to be one of those guys where I was like, I don't pay attention to the news. I don't really care. They can do whatever they want. I'm going to be good, right? I'm going to be okay. I really can't do that for a lot of reasons, right? Obviously, there are the ethical reasons where I really want to participate and I really want to engage in kind of the future of myself and my brothers and sisters around me, but also especially with crypto. And this kind of leads into the question below, which is, I don't get a simple thing. What's the basic goal of smart contracts, which I really want to get to. But yeah, it leads to down below because I think this is so important. And it's in my mind, it's my duty to educate people why this is so important, because I want to live in a better world, basically. So do I think that governance and legislation is a little bit behind? Yes, but I don't think it's like, like they need to be faster. I mean, they're methodical creatures, right? There's a reason that they are where they are and they have the rules in place. There's a reason that sometimes it can be hard to change things because if stuff is super easy to change, again, we're getting to philosophy a little bit here. If stuff was super easy to change, then maybe we would change on kind of on a whim, right? Oh, like maybe 1 year we all hate, oranges and we ban oranges, and then we realize that that's insane, so we unban oranges and we just don't have any stability. So yeah, I think legislation today is a little bit behind, but I don't think that's any fault of their own. I think this technology is cutting edge. Obviously, more and more people are understanding the value here, and they will catch up at some point. And does it limit your work somehow? Not really, because that kind of is my work. It kind of is our work, right? Like I teach engineers how to become blockchain engineers. I teach engineers, why blockchain is so fantastic. I build fantastic tools. I make cool things myself. And yeah, it would be great if there was more adoption so more people could use them. But I wouldn't say it limits my work in any way. I would say there's probably more than our fair share of work here. I don't know if you had anything else to comment there, Andy.
Oh, I have a million things to say, but I really want to hear your answer to this. What's the basic goal of a smart contract? We'll save it for another time. Okay,
cool. How many proof of work exists in general, and what about their energy cost to perform them? A lot. I think the question here is how many proof of work blockchains are there, and there are a lot. Yes, proof of work is very energy intensive. And that's actually why Ethereum, for example, has moved to proof of stake, which is way less energy intensive. Yeah, proof of work, all your little computers basically have their foot glued to the gas pedal. And yeah, it takes a lot. I think this will be, it'll be interesting to see kind of how the nature of blockchains shift their consensus protocols to adhere to this. But yeah, right now there are a lot. There might be less in the future.
I just want to chip in on this one. Yeah, there are significant energy consumption for Bitcoin in particular, but proof of work blockchains in general. But there are for Christmas lights too. And there are for the amount of televisions that are turned off in standby mode draining energy. And so we as a society and as individuals need to decide, where do you find utility? So there are just as many examples of people burning coal to spin up Bitcoin mines. There are examples of people using solar and renewables and using those funds to fund more efficient renewables. So that's a very complex discussion that I think it's being taken as like a hot take, quick click headline lately as Bitcoin and crypto has risen to the surface of the social consciousness. But it's a much more complicated question, and there are pros and cons to proof of work.
Questions. These are like deep philosophy questions. It's great. One of these days we'll have a technical question. But all right, so next question. So this is yeah, we probably should have started more with this, right? I don't get a very simple thing. What's the basic goal of a smart contract? Fantastic question, because that kind of is like, okay, why are we even here? Right now, I think the easiest example, and we were talking about this internally a lot, was everything that happened with GameStop recently was a giant smart contract commercial, right? The reason that the retail investors were so invested, or actually, let me back up. For those of you who weren't paying attention to kind of that whole fiasco, is a couple weeks ago, the markets, basically a lot of market makers, a lot of brokerages shut off trading of a few specific securities, like GameStop, for example. This infuriated people because they thought that due to a lot of these large hedge funds having vested interest that GameStop and these shares went down in price, they were purposely manipulating the market and screwing over the retail investors. Now, there are a ton of issues with this right here. The first is this issue that we were talking about a lot, which is trust. We have these systems in place where we have to trust a single centralized entity to behave honestly. So we have these stock exchanges where we have to trust that these single corporations are going to do the right thing. And if you know anything about business, that is typically not what they talk about in their quarterly meetings. They don't talk about how much good they've done. They talk about how much good they've done for them, how much money they've brought in. And to be honest, it's really no fault of their own. The incentives for them to get money are there. They're incentivized to do this. So because they're incentivized to bring about the most wealth or the most good to their own company, they have a disproportionately incorrect or disaligned incentive to behave maliciously or behave however necessary against the people that they're working with. Another great example is insurance. Insurance companies are, contrary to, well, non-popular belief, insurance companies aren't around to be kind of this saving grace, right? Insurance companies are around to make money. That's the reason that they got into business. It wouldn't be sustainable for them to be in business otherwise. So they have a duty to bail you out when you get in trouble. However, at the same time, they have a duty to make money. So they have this massive conflict of interest. And because they're a centralized entity, this is a huge issue. It's the same thing with GameStop and with these stock exchanges. They have this huge conflict of interest. They want to service the customers, service the clients, but at the same time, if those clients are making them lose money, well, they don't want to service them anymore. And since they have the power, which is the second big issue, they have the power to turn off the market or turn off the ones that they have this conflict with. Sometimes they do. And this is a huge issue, right? Because if your livelihood depends on this, you now have to trust this sole person is going to take care of you and is going to do right by you, which, as we've seen with GameStop, as we've seen with bad faith insurance and plenty of other organizations that we have to trust, this doesn't always happen. So smart contracts are really solving this issue of trust and automation. And we see a ton of value here. And one of the easiest, I think there's a ton of easy examples. One of the other easy examples is just with all of DeFi. So I came from the hedge fund world. I worked at a hedge fund for a couple of years. And if anybody's familiar with the book Flash Boys or wants to learn about kind of some crazy high frequency traders and how they were manipulating the market, it's a great book. I highly recommend you read it. But there's this issue where the market wasn't fair, right? The market wasn't even fair for the hedge funds because the high frequency traders were taking advantage of everybody. And it was because, again, there were these disaligned incentives. where the people in power, we had to trust the people in power, the people running the exchanges, or they were screwing you over. So it's due to these things that people have basically with blockchain said, we now have the power to disperse these pockets of power to the people. And that way we don't have to trust that these centralized intermediaries who don't have incentives to do what's right by us have to do what's right by us. So a decentralized blockchain, if you do right by yourself, the incentive there is doing right by yourself also does right by everybody else. So now you have the incentives properly aligned with smart contracts versus in our traditional world, they're not. So so this is the part that I get the most kind of animated about and I'm the most excited about, but really the list kind of goes on and on. I mean, let
me give one super simple, one hyper simple example. No, I love it. So if you look at an exchange, so a centralized exchange, when you want to exchange Bitcoin for Ethereum, for example, there's a rate and you do it on their platform. It's a web app, it's hosted by them, they run everything, and you can withdraw that money, to your bank or whatever. It all works on their platform. They can turn it off. They can not pay their hosting bill. They could do, there's a whole bunch of things that could happen. And most centralized exchanges, they try to do a really good job of building reliability and security into their systems and not shutting down trading, but they can. And some do. And we have seen it actually just a couple of weeks ago. A major centralized exchange turned off withdrawals for Ethereum because the costs were really high. They had a good reason, a good business reason, but it was so expensive to transact on the Ethereum network that they turned off withdrawals for a period of time. Smart contracts, you can build a decentralized exchange. And there are many examples of decentralized exchanges. Bancor is a great one that uses Chainlink nodes. You can't turn it off. You can't turn the smart contracts off. They're open source. They run, and they're run because they're run by a decentralized network of Ethereum nodes. So that's the why, is you can't turn it off. There is transparency embedded. It's the things that come with a blockchain, those benefits of a blockchain, that we can then move to the application layer. That's what a smart contract really is. And then, as Patrick went on, there's all sorts of great use cases for that, and where we take away just misaligned incentives and things like that.
So yeah, thanks for cutting me off. Actually, I was getting a little carried away. So I break down kind of the need for smart contracts in today's society into four simpler pieces. Number one is to break up the extreme power disparity and the extreme centrality. Number two is to break up and remove this conflict of interest between the protocol and the user. Number three is to have a automatic enforcement procedure where all transactions and all digital agreements are automatically executed and automatically enforced without having to wait on the other party. And then the last one is transparency. So this one I think is actually massive. Everything on chain is 100% readable by everybody else. And having these transparent rules and these transparent code as law agreements means that at all times you know exactly how something is going to play out, and you never have to worry, okay, are they going to do the right thing? So again, I think those four kind of huge ones, I think the list could probably go on. For me, those are the big four reasons. So great question, fundamental question. And we have like 2 minutes left.
Let's do some lightning. We have 15 minutes or
15 minutes, 2 minutes?
Let's do some lightning round.
Okay, we'll do lightning round. Okay, is it possible to build a smart contract using a functional language like Haskell instead of imperative one? I'm going to answer this one. Yes. So Haskell is currently, I believe, what's going to be used by Cardano. For those of you who asked me about that. But yeah, you can, a smart contract can be written in whatever language the core developers feel like writing it in. Andy, anything to add?
Nope, I'll take the next one. Asking about the link and the wallets, I'm going to refer you to the Chainlink white paper. It explains token distribution, the wallets, the incentives, and everybody that has there. There's a lot of fun that goes on around Chainlink. The network, go read up yourself. There's a lot of resources out there we can't comment on right now.
Yeah, we'll talk exactly about distribution and everything there. So what do you think of the most recent Nano and Solana network? No mining required, eco-friendly, fee less and very small fee, fast and scalable. Why is still Bitcoin on the lead? Where is the point? Thanks. Okay, so
let me start. Yeah. Bitcoin is in the lead because it has the largest network. It's the largest, most secure, most robust network. So it has the most stable value. People have heard about it. It's been around for the longest in terms of crypto. So that's why it has the market cap that it does. It's a great, stable cryptocurrency. I love Nano and Solana. I think there's great reasons to use other networks. I love Ethereum. I love them all. Like, I'm a big fan of all of them for many reasons. I love Dogecoin. I think it's fantastic. Yeah, that's how I learned about crypto. Is I got into mining Dogecoin. I was like, oh, that's no risk. It's a meme coin. It's worth a couple of cents. So there is a good reasons for a lot of different blockchains, and I think we're going to see a lot of cross-chain and multi-chain solutions in the very near future.
Yeah. So, and then just add to that, I know we're rapid firing. I was actually flipping around. Sorry. Each one of these chains do different things, so that's important to know too. Solana, for example, is a smart contract platform. Bitcoin is not. Bitcoin is a proof of value chain, or excuse me, not proof of value, is a store of value chain where you store your value. Solana is, and Chainlink is actually open on Solana too. They all do different things, and it's important to know, okay, what is the value that this chain brings, and they each bring different value. And so I think if you're looking at that.
Real quick, there is a smart contract platform that's a side chain of Bitcoin. So they have smart contracts. It's called RSK. They use Chainlink, and then they validate on the Bitcoin blockchain. We're actually doing a video interview. I'm doing a video interview with them tomorrow on the Chainlink YouTube channel. So there's a plug. You can go learn a little bit about Bitcoin and smart contracts tomorrow from Dr.
Awesome.
Boyan.
OCR recently launched, but Link will still be running Flux on. This is a in the know question. Recently launched, but Link will still be running Flux on parallel for redundancy and security. Is it currently profitable to run a Link node in these conditions? Yes. Yeah.
OCR, for those who are new, is we just had a major version release for Chainlink that makes it a lot cheaper for node operators, the ones who are calling the data and then submitting it on chain. Makes it a lot cheaper for them to run the node, and therefore we can have more nodes, we can get more data, we can do a lot more stuff. So increases decentralization, increases speed. It's really great. And then the Flux version, it's a version redundancy. So if anything goes wrong with OCR, we got a backup. We actually have 2 backups because there's one before that. So we love that model. It's like really strengthening the system redundancies, because our goal, we want to see billion-dollar transactions with Chainlink. We want to see JP Morgan come in and send $1 billion to somewhere. And they know that they can do that securely because we've got the best oracles, and you can have an on-chain auditing trail and all that. That's one of our major goals is we want to make this secure, usable, fantastic. This has been super fun.
I was gonna say, yeah, this has been a lot of fun. I feel like there's like a ton of conversation here. I love all the questions here. I kind of want to do one more. I'll do a quick tutorial. So we didn't get to all the technical pieces here, but if you head over to the documentation, everything that you need to know is here. But I do want to show you this last one because this shows the request and receive model of Chainlink and kind of the core functionality. So if we're looking at this data.feed.link, although yes, as one of you pointed out, with OCR and Flux Monitor, it's a little bit different. But basically, what's happening is this smart contract is requesting data from each one of these nodes, right? And so to do that, we actually have to use what's called a request and receive model. So we're going to see that with getting a random number, a verifiably random number with the Chainlink VRF. And again, we're not going to have time to go to it. But if you want to get any data from like an API, you can go to this one down here, make a GET request. It's really kind of the core fundamental piece of Chainlink that kind of allows this all to happen is making API calls, because that's how the internet talks to each other. So get a random number. Everything you need to know is in here. We're going to deploy. I'm going to be kind of quick through this. But again, we're using Remix here. Just on the side, random number consumer. I'm going to briefly talk through this. Again, we're importing from GitHub. One of the couple of the key differences here is our contract is now inheriting. This is Solidity's version of inheritance. We just say contract is VRF consumer. And this is our constructor. So when we deploy this smart contract, we run this constructor first, and we actually need to give it the address of the VRF coordinator and the link token. So the VRF coordinator is actually an on-chain contract that's already been deployed that cryptographically guarantees and checks to make sure that our smart contracts, that the random number returned into our smart contract is actually provably and cryptographically proven to be random, which is an insane feat. We need the address of the Chainlink token because that's actually the currency that's used to work with these oracles. And then we need a key hash, which defines the specific oracle, and then the fee. When making transactions on Ethereum or any smart contract platform, you generally have to pay some type of computation fee. With working with oracles, it's the same. You just pay an oracle fee, and that goes to the node operators. And then we just have this function, get random number, which calls this other function, request randomness, which is imported from that inheritance that we did. And this actually makes an async request. So request randomness emits a log off the chain. There's an off-chain Chainlink node looking for this log. It picks it up. It goes, oh, okay, I'm going to get your random number. And then it returns the random number by actually calling this fulfill randomness function. Well, technically, it calls the VRF coordinator contract, but for simplicity, let's just say it calls the VRF, the fulfill randomness function here. It calls it and it returns the data in this randomness object here, and then we can view what the random number is. So let's go ahead and compile this. We're going to deploy it. Again, we have to use the testnet, because if we use a VM, the nodes aren't watching like a local testnet that we spin up. We want to use a testnet the nodes are actually paying attention to. So we're going to hit deploy. Again, MetaMask popped up. I hit confirm. You guys can see it. Again, once this finishes deploying, we get this contract at the bottom here. And this is the one thing that we're going to do here that we didn't do before. If I try to call this get random number function now, we get this gas estimation error. So what we need to do is we actually need to fuel the contract with the link token. And you guys actually can't see me do it because of sharing screen, but I'm sending my contract here like a link, although the fee is much less for this one, and it changes network to network. I think on Matic, it's like 0.0001 link or something like that, which is like a quarter of a quarter, or a penny or something, I forget. But once we send it, then we can actually hit this get random number function. And I'm going to hit confirm on MetaMask. Sorry, you guys can't see it. But again, this kicks off this transaction, and we actually need to wait for this transaction to complete, and then the Chainlink node to pick up on the transaction, say, okay, they want a random number, and then return the random number. So this request receive is actually asynchronous, for those of you who are familiar with that, and it actually will make a second transaction back. For those of you JavaScript engineers, you know what I'm talking about. Oh, and then, sorry, I didn't show you what random result was before. It was 0 before, but now when we hit random result, we can see the random number here. So that's the basic kind of request and receive. Obviously, you know, the get any API, this is kind of how you can customize your smart contracts to really do anything. Any data that you want, any computation that you want done, you wrap it in an API, you call it right here, and you now have an unlimited, a limitless smart contract functionality. So we'll grab the rest of the QAs, and this has been great. Okay, so Solidity is just, I'll stop sharing. So Solidity is just a language that makes easy to build smart contract, right? But is it possible to build smart contracts with any other language? Great question. So basically, yes, Solidity is a programming language designed to be compatible with the EVM, or the Ethereum Virtual Machine. So it was built by the Ethereum Foundation for the purpose of building these and deploying these smart contracts on the Ethereum chain. But depending on the platform that you're working on, depending on if they have Solidity or EVM compatibility, you could use other languages. So on Ethereum, you really can only use Solidity and this other one called Viper. Those are the two languages that you can use. But on Solana, for example, you write the smart contracts in Rust. And then on Polkadot, you can use Ink, you can use Solidity, depending on the parachain. So most blockchains have kind of their own language, although the majority of them are EVM compatible. And because they're EVM compatible, you can write your smart contracts in Solidity, which is really nice. What are skills needed for the hackathon? Just a good attitude, willingness to learn. So honestly, like if you're brand new to this, come. The workshops will go through everything. Ask a ton of questions. Curiosity is a skill that's needed. Don't be afraid to ask questions. Learn from other people. Again, there's this thing called imposter syndrome. A lot of people have, and they feel like, "Ooh, I can't ask a question because I'm gonna, people are gonna think I'm stupid or whatever." That is absolutely not the case. Especially since this technology is so emerging. And so new and so budding. Everyone's on a spectrum of capability. So 1,000%, it's literally just have a good attitude, show up, have fun, want to learn, a willingness to learn, and a willingness to put in the work kind of with your teammates.
Hey, one more plug for the hackathon. Projects need React developers. Projects need a front end. It's not all smart contract development. Projects need designers. You wouldn't believe how many amazing projects there are that, with some good design and just a little UI work, it makes them really pop and stand out and take them to the next level. So if your skill set is not in Solidity, that's okay. You can learn it on the side as you go through. There's a ton of good ways to contribute and be a part of this. Even making the video, you got to do a wrap-up video at the end and tell me if you've got those skills and you don't have technical skills, be a part of that. So many of these projects turn into entrepreneurial endeavors. A lot of these projects, just get you exposed to other communities where there's even more developers and builders. We've got over 2,000 registrations right now, and there's still time to go. So it's one of the largest in the space. There's tons of people. Like Patrick said before, all the major projects come and they build with us because you need oracles for everything. Everything cool you want to do, you need oracles. We're the best oracle. Come to the Chainlink Hackathon and check it out. And at bare minimum, register and go check out. Patrick has some like a week long of Solidity tutorials and those starter things that he blazed through this time. But you'll be able to see all the steps and run through it synonymously.
For sure, and even to add on more to what Andy just said there, a lot of the projects that we've seen that do really well, they usually do actually have one non-technical member, like a project manager or somebody who's in the know or who has kind of the idea or what it should look like. But yeah, there's a lot more to a really good.
Just somebody to text the lead dev and say, "Get up, we have a deadline." Seriously, that's super valuable because you got to sleep too.
There's a lot more than just knowing how to code, but obviously knowing how to code is you probably need at least one person, and by probably I mean you definitely need at least one person. And then feel free to cut us off. I guess we'll rip through the rest of the questions here. Is Chainlink working to build a language that I might have missed another question. I apologize if I do. Is Chainlink working to build a language that would be compatible with other blockchains? So I guess I'll just answer that right there. No. So Chainlink. So building a language that's compatible with other blockchains, basically you would have to customize that language for every new blockchain, which is really tricky. I'm studying Haskell at the moment, so I'm actually restricted to the Cardano blockchain. When they will release smart contracts, should be Q2. So Chainlink isn't developing any languages. I mean, Chainlink is really there to empower whatever you already have with external data. So if you have Haskell, as your language and you're building with Cardano, great. Chainlink can help connect your blockchain or help connect your Cardano or your Haskell blockchain to external data or to other blockchains. Chainlink itself isn't, building, layer one solutions here.
Hey, a lot of times what we do for a chain or a language that is not native to our stack is there are a bunch of grants, community grants that we'll give out to an organization to develop that. So, I mean, I can't think of them off the top of my head. If you go to the Chainlink Twitter page and scroll through, it'll say grant awarded to somebody to do this. And a lot of them are to make sure that we have that native integration of Chainlink oracles on whatever EVM it happens to be. So if that's something you're excited about, apply, get a group of people together. And once Cardano's got smart contracts, let's get it going, right? That's a great place for you to make an impact in both communities there or find people that do. So that's usually how we approach that. In the meantime, there are external adapters that can do some of that. And I'm not exactly sure how that works. But the Hackathon is probably a good place to play with that a bit.
I am exactly sure how that works. So feel free to ping us and go to the external adapters webinar. What do you think about the blockchain domains like Unstoppable Domains? Do they have a future in your opinion? I think they are the future in my opinion. I mean, current domain name servers are all centralized servers. Imagine if we had a decentralized one. I feel like that would be a net good for the world.
I saw a really cool panel last year. It was a guy from Handshake, guy from Unstoppable, guy from ENS, and a guy who was participated with ICANN, he was involved in the organization, and they had it out on stage, and it was actually kind of intense. It was a really great panel. I don't think Handshake was there now that I think about it, but it was a really great panel, and it talked about there are strengths and weaknesses of ICANN, and they're relatively decentralized. They try to do good, according to this guy, but there is room for disintermediation there, especially if there's value. If you see a lot of censorship, there's a lot of value there for maybe not for the world, but for a lot of places. Decentralized web in general. There's Amazon AWS competitors that are coming out of the woodwork that are great. That's distributed compute. Or storage, or all sorts of different models that are coming. So I'm pretty excited about the decentralized web infrastructure. We're part of that. The Graph, they're coming on next. They're another part of that DWeb infrastructure. We love seeing that stuff.
100%. How price feeds from Chainlink help with flash loans? Is it still possible to find noticeable discrepancy between oracles? My answer to this is basically the reason why like Aave and Synthetics and friends have not been hit by flash loan attacks is because they're using Chainlink oracles. If you use a flash loan to basically half the attacks that we've seen that use flash loans are actually oracle manipulation attacks. So like they'll take out a flash loan, they'll crash the price of an asset because they'll take out like a $10 billion loan or whatever it is, make some trade which destroys an asset, and then they'll make another trade really quickly based off of that new price. Using Chainlink price feeds, you actually can't do that, because even if you crashed, several places that the oracles are grabbing data from, there's so many oracles, and it's centralized that it protects against that. So also each oracle is typically aggregating from multiple sources themselves, so they also have protections against that. So flash loans have been protected against with all the protocols that are using Chainlink.
Now, flash loans are actually really cool DeFi primitives, things that you can do. They're not always used for evil.
Yes.
so throwing back to an earlier question about like what's the point of smart contracts, you could do something like a flash loan where you collateralize a loan, you take out a loan, you conduct the transaction, you repay the loan all in the same block. Like you can do it in a 6-minute interval or in a 30-second interval, or however short the block is. You can execute these hyper-fast automated logic loops with massive amounts of value, or whatever amount of value you need, and it changes the way finance is modeled, right? It really brings to light some other options. So yeah, you can throw in $100,000. It's not that much money. You can get $100,000 and collateralize it, and you got $100 million. You could do this massive stuff, and you got it for 30 seconds. You can do a lot of stuff with that. So that's just another example of a really interesting product.
The other thing that I just kind of real quick on flash loans is I actually think flash loans are really good for the whole ecosystem as a whole, because if your platform is vulnerable to flash loans attacks, that means you're vulnerable to whale attacks. So if you're getting hit by a flash loan attacks, it means somebody else who just had a lot of money could also crash your protocol. So just a quick note on flash loans there. Your honest opinion. Maybe we'll skip that one for now. This isn't. I don't think we're gonna jump.
There are great resources online that compare Chainlink to Bend, and you can go and look those up.
Yeah,
I would encourage that.
That's a longer conversation, and that's not what we're here for. For Patrick, oh wow, are you personally involved with the development of staking? Can you disclose how close you are to completing this milestone? I'm assuming you're talking about Chainlink staking. I'm not working on building that, so no, I have no idea. Something that's actually important to know about Chainlink and most DeFi protocols in general, actually, or most decentralized protocols in general. Typically, there aren't really roadmaps because the world changes so fast, and teams need to account for basically the new changes and the new turns of the tide. So I can't answer that because I'm not working on it, and even if I was, I probably wouldn't be able to answer it, to be honest. So sorry. Good question though.
Cool. Here's one thing: we don't release stuff for publicity. We release stuff when it's good and when it works. So I have no idea timeline and who's working on what, but like it's not out. I think there's a good reason for that. I trust the process. Trust. There we go again.
For sure. Well, all right, cool. Well, we've definitely been here a little bit longer than first anticipated, but thank you to everyone. What was that?
No problem at all. It was really awesome content. I don't know if you guys went 5 minutes, 10 minutes, 20 minutes, it would have been okay either way, because like we don't really get this kind of information, this kind of valuable knowledge in class. It's not like we have a lot of resources in either like in any university at this point to explore this fascinating world. And these technologies are super new, innovative, they are emerging. So getting this shot at understanding what a project like Chainlink is doing for us is priceless. I know that lots of these things were probably a little bit over the head of some people. Some others were super experienced, but that's the case on many technologies. So hopefully a lot of people found this interesting. We planted that seed in them of the blockchain, of Chainlink. They'll get more interested into this stuff. For sure, check out the hackathon. I checked it out myself. I'll probably register if I have the time to do it. So super interesting stuff. We got a lot of engagement from our students during this event, which is amazing. And from me, from all the core team, thanks a lot. I don't know if you guys want to add something else, but there seems to be even more questions. We'll for sure make a compilation of all of them. Don't worry about it. We're going long. We'll include them in our YouTube recording, because we are recording this whole thing. We'll post it either later tonight, tomorrow morning. But yeah, awesome stuff.
Great. You can follow Chainlink on Twitter and all our social accounts. You can follow Patrick and I both. We're easy to find if you just go to Twitter. That's kind of the crypto hub of social information. And then keep an eye on other social platforms. The technical Discord, of course. We're going to start stuff on Clubhouse soon. We're going to be everywhere. So you can find us. You can @ us individually. There's a ton of places. This has been an absolute pleasure. Nice to talk to students again. And your questions, fantastic. Thank you so much for being a smart, capable group. Looking forward to seeing you all, your hackathon projects.
Thank you so much, Patrick and Andy. And we're looking forward to new updates on Chainlink and the rest of the blockchain ecosystem. And thank you, everyone, for attending the event. We'll keep you posted. Bye, everyone.
Thanks so much. Bye-bye.
Thank you.